going to work on line of best fit. Okay, a line of best fit is a line that we fit to a set of data that is the best representation for the data. Okay, now typically when we graph a group of data, okay, there's been a lot of different representations that you guys have seen so far. You've done dot plots, you've done two-way tables, you've done different things, right? Today we're going to be working with sets of data that have two variables, okay? One of them is called the independent variable, and one of them is called the dependent variable, okay? The independent variable is going to be represented by x, okay? So this is represented by your x values. The dependent variable is going to be represented by y, okay? Did any of you guys learn, like in bio, when you're doing testing in bio, like the independent variable stays the same and the dependent variable changes, right? Okay, so the independent variable in math isn't necessarily always staying the same, but this variable is causing the change. This causes the change in the other variable. Okay? So x is the one that causes the change. Y is the one that is like, kind of like, you could call it reactive. Okay? It's reacting to what's happening with x. Okay? All right, now, when we graph this XY data, we typically get something called a scatter plot. Okay? So a scatter plot is a graph of a bunch of points on the graph, and sometimes we see things that are called correlations, right? Have you guys learned about correlation before?
Yeah.
A little bit? Okay. So we have different types of correlations, okay? So if I were to take my pencil and just think about, like, if this data was actually a line, which direction would it be going? Would it be going uphill, positive slope, or would it be going downhill, negative slope? Downhill, right? This is what we call a negative correlation. Okay? The correlation is negative because if I were to fit a line to that data, it would be going downhill. It would have a negative slope, right? Remember learning about slope last semester. Okay? Now, look at this data here. Is it going uphill or is it going downhill? Can you tell? No. This means that it has no correlation. Okay, it's neither going uphill or downhill. All right, now let's look at the last data set. What do you guys think? Uphill or downhill? Uphill, so that means it's positive because we call an uphill slope positive, so we also call this correlation positive. Okay? All right, now today I told you guys we're going to be working on line of best fit, and when we're dealing with line of best fit, for today, we're just going to be kind of eyeballing it, okay? So doing our best guesstimate of where the line of best fit is. Now, what you can use is you can use your ID card, you can use a ruler, but what we're doing when we're drawing a line of best fit is we're trying to draw a line through the data that we think is the best representation of the data. So if I drew my line like this, would that be a good representation, drawing my line that way? What about drawing it this way? No. Okay, so I want to try to get my line through most of the data in what I think is the best fit. So I'm going to draw my line something like that. I want you guys to draw your line right now. Okay? Now, can you draw a line of best fit for the second one? No. So I'm just going to write on this one, cannot be determined, because is there any correlation here between the x and the y? No, there's no correlation, right? Okay. What about the last one? Could you guys possibly draw a line that would kind of represent that data? I mean, I know it's not as nice as this one, but could I pick a line there that would kind of make sense? Maybe something like that. Okay. So let's go ahead and draw a line of best fit for this data here. So that's kind of going through like the center of the data, trying to just do the best job I can. Okay? It's not perfect, but it's kind of right there in the middle. Okay, are we okay with how we did that? Okay, if you're ready, go ahead and flip over to the back side of your page. Okay. Okay, let's take a look at the back side. Okay, so on the back side it says draw the line of best fit and write an equation of the line and slope intercept form. Well, the line's already been drawn for you. Okay, so that way we're working with the same line. But what we are going to do is we're going to write the equation of our line of best fit in slope intercept form. Do you guys remember from first semester what slope intercept form is? What is the form for slope intercept? Mx plus b. What did the m represent? Slope. What did the b represent? The y-intercept, right? Okay. So once we've drawn our line of best fit, I can write the equation of the line by picking two good points from the line and then finding the slope and finding the y-intercept. Now, when I pick my two good points, they could potentially be points that are different than the points that are already there, okay? So I don't see an actual point here, but it looks like it crosses through 0, 0, so I'm going to use this point right here. Bless you. Okay, now another point that I could potentially use would be maybe I see a point right here. This is an existing point already, right? Right here. Let's pick that point. Okay, now there's a couple different ways to find the slope. We could write down the points and use the slope formula. You guys remember the slope formula? y2 minus y1 over x2 minus x1. But that kind of takes a long time, right? How else could we find the slope not using the formula? Rise over run. Okay, let's do the rise over run. So let's count. How much do I rise? 1, 2, 3, 4, 5, 6, 7, 8. Okay? Now, how much do I run here? 1, 2, 3, 4, 5, 6, 7. Okay, so it says draw the line of best fit, choose 2 points, which I did. Okay, I'm going to put a check mark in box B because I did that step. Okay, then it says find the slope using those points. Well, I found part of the slope is 8. That's my rise. What's my run? 7. Okay. So I've got my slope now. This is the slope. Okay, then it says, use the slope in one of the points to substitute and solve for B. Well, I only need to do steps D and E if I can't see where the y-intercept is. Can I see where the y-intercept is here? No? What about this point that's right on the y-axis? Can you guys see that? What point is that for your y-intercept? 0, okay? So in this case, I'm going to skip step D and write that my y-intercept is 0. Okay? And so now, can I write my last part, which is the equation of the line? Okay? So what is the equation of the line? Y equals what? 8 over 7 x plus 0. Now, do you really need to write plus 0? Okay, can we just write this for our equation? Okay. All right, so let's look at the second problem. Okay? So the second problem is, let me pull it back down. Okay? I have a line. Let's pick 2 really good points on this line. I think the line is crossing through the grid lines right here. Do you guys see that? It's 6, 4 right here. I can pick a point that's not one of the existing points to use. Okay? Another good point that I think I see is I think it's crossing the y-axis right here. Do you guys see that? Right there. Okay? All right. So now let's find your slope. Okay? So let's find your rise. Did I go down 5? Is that my rise? Let's find your run. I went over 6. Okay, so I use my 2 points to find my slope. My slope is -5 over 6. Okay. Now, can I see where my y-intercept is here? What value is my y-intercept on? What is the value for my y-intercept up here? 10? 9? 9, okay? So let's write down my y-intercept is 9. And now can I write the equation of my line? Y equals -5 over 6 x. Do I need to write plus 9? Yes, I do, because that's actually not 0, right? Does that make sense there? Okay. Now, let's look at the last example. Okay. On the last example, let's pick 2 good points to use. Can anyone find a good point that they think is crossing nicely through grid lines? Maybe here. Does that look like an okay point? Okay. That one? Right there? Okay. Is there another good point that I can use? This one's really not the best line because it's kind of a little slightly bit off. But let's just find one more point that you guys think is the best one. Which one do you guys want to use? As I go down my line, do you want to use this? Do you want to use this? Do you want to use this? This one? I know it's a little tiny bit off, but remember, our original sketch was just an estimate, right? So would it be easy to just redraw this line so it goes exactly through there? It would, okay? Yes? Yeah, go ahead. Okay, so let's use these 2 points, okay? So find your slope. What is your slope? How much do you rise? 4. How much do you run? 4. Okay, now, if you get a slope of 4 over 4, do you need to reduce it? What is your slope? 1, okay? Now, can I see where the y-intercept is? Yeah, I'm going to skip that for now, okay? And so I get my y-intercept is at 0. So what is my equation? Y equals what? 1x plus 0. Well, do I really need to write 1x plus 0? How could I really make this simplified? What would I write? Do I even need to write 1 times x? What's 1 times x? X. So this could be my final answer. Does that make sense there?